MSI highlights benefits of CAMM2 DDR5 memory for desktop PCs. Shorter traces lead to higher speeds and lower latencies, cooler and innovative designs. CAMM2 memory modules will soon be seeing their debut on desktop PCs, and MSI has highlighted some of the major benefits for the platform. CAMM2 memory will support dual-channel design on a single module, cooler design in compact form, replaceable connectors for easy motherboard repairs. The CAMM2 standard has already been made official by JEDEC, and the firm also confirmed CAMM2 for desktops, which will be a major shift from the traditional SODIMM modules that the platform is used to. Designed initially as a means to save space on mobile platforms such as laptops and smartphones, the PC industry saw the potential of CAMM2 beyond these two segments, and this year, we saw several companies such as MSI, Asus, and ASRock come forward with their first motherboards to support CAMM2 modules. This marks the beginning of the CAMM2 era for desktops, and MSI has now provided a more detailed insight into how desktop PCs will benefit from the standard during an insider livestream. CAMM2 for desktop PCs: faster speeds, lower latencies, lower power, low cost. Starting with the most obvious benefit of CAMM2, unlike SODIMM memory, which has system interface stubs embedded within the motherboard's PCB, which reduces the platform capabilities for bus speed, a CAMM2 interface is directly connected to the CAMM2 modules. Both the inner and outer connections of the IMC are connected to CAMM2 modules, leading to higher signal integrity and better performance. This also leads to less complexity, since you often find lots of signal traces on a motherboard, between the CPU and the DIMM slots. CAMM2 motherboards require fewer signal traces, which can also lead to cost benefits for manufacturers. Another benefit of being connected closely and directly to the CPU IMC is that both the inner and outer channels lead directly to a single CAMM2 module, and which allows for dual channel operations on a single stick instead of SODIMM, where you need to have two modules to enable dual channel operations. A multi-DIMM solution such as SODIMM interfaces will lead to higher memory capacities and dual channel capabilities, but it will also run slower as the bus capabilities take an impact going through a multiple set of DRAM modules. That's why single channel memory is usually run when setting awk world records, as 2DIMM and 4DIMM configurations can lead to overloading of the IMC. This is also why many ITX motherboards tend to have better signal integrity, since the DIMMs are routed closer to the socket and there's less distance for the signal to travel between the CPU IMC and the modules. CAMM2 is just one module that supports dual channel mode, leading to higher speeds, but JEDEC did specify a dual DIMM CAMM2 design. It's relatively complex to implement, but that won't be needed besides a certain niche. Diving into the cost savings achieved through CAMM2 modules. The fewer signal traces are one way that achieve lower costs. The other is the overall design of the CAMM2 modules, which is beneficial for memory makers. CAMM2 modules have a smaller PCB than SODIMM modules, leading to less material of use, and since there's only one module, only a single MIC, power management integrated circuits, is used. On a SODIMM setup, each module has its own MIC. That also leads to power savings, as multiple NICs can increase the overall power consumption for the memory, and more importantly, it also means less heat, so you can essentially run CAMM2 modules bare of heat sinks. New motherboard designs, heat sinks and RGB included now. In terms of design, the CAMM2 DDR5 memory not only consumes lower power but also receives better cooling. A SODIMM memory will usually block the airflow to the CPU, since they are sitting right next to the socket, and the faster DIMMs feature large heat sinks. Furthermore, the rightmost DIMM is always blocking airflow to the rest of the DIMMs installed behind them. That's not the case with CAMM2, since it lays down flat, which means that the CPU gets extra airflow, and flattened heat sinks can be implemented, which deliver good cooling to the attached memory. That doesn't mean that cooling vendors won't have some fancy new solutions for CAMM2 DDR5 memory modules. Partners such as BitsPower have already showcased custom loop water blocks for CAMM2, which look great but might be a tad bit overkill. Motherboard vendors such as MSI do have their heat sinks for their Z790 Project Zero Plus, which was a design that was made in partnership with DIY Ape. Here's our hands-on with the board during Computex 2024. Asus also showcased its ROG Maximus Z890 Hero BTF running CAMM2 DDR5 memory at 8000 mount S speeds with sub-50 temps under ambient cooling. ASRock unveiled their Teak Formula CAMM2 design, which is geared towards hardcore overclockers. This backside connector motherboard has an aluminum heatsink for the CAMM2 memory, which also features RGB. So while the memory itself won't feature any RGB, the heatsink and cover plates designed by motherboard vendors should incorporate fancy looks to retain some of that RGB lit flashy nature that we have come to expect from gaming DDR5 modules. MSI's CAMM2 heatsink comes in a toolless design and has a thermal pad on the module and one on the motherboard's PCB, which directs heat to a metal-based mounting bracket on the back. The backside also requires cooling since certain CAMM2 DDR5 modules, mostly dual-channel designs, will feature DRAMICs on the backside too, so those need to be cooled too. Better repairability thanks to replaceable connectors, but first general requires screws. Next up, we have to talk about the compressed attached connector. This connector is going to make motherboard repairs a whole lot easier, especially DIMM slot repairs. So how the newer connector works is that there are three parts. First, there's the connector that connects directly to the motherboard, but it isn't soldered. It can be removed easily and there's only one way it fits into place, so you can't go wrong with the connection procedure. The connectors feature LGA contact pads on the top and bottom. The bottom pads connect to the motherboard while the top pads connect to the CAMM2 modules. On existing designs, if the SODIMM slot gets damaged, then you'd have to RMA the entire board, but in the case of CAMM2's connector, you would only need to get a new connector is said to be readily available and will be compatible across all motherboards and platforms. This connector is going to come in single and dual channel designs, and what you are looking at right now is a dual channel CAMM2 connector. The single channel has half the amount of contact pads and is slightly slimmer, but desktop PCs will leverage dual channel designs. If the CAMM2 memory is defective, then you can get it replaced easily since all memory suppliers, SK Hynix, Samsung, Micron, have them mass-produced and offered through manufacturers such as Crucial, Guile, G.Skill, Cliv, T-Force, and others. A design change has also been made to the motherboards to accommodate the new CAMM2 connectors. Since the CAMM2 memory comes in various capacities, up to 256 GB, they will be slightly wider, and the 24-pin connector has been moved to the top of the motherboard instead of laying right next to the DIMM slots. CAMM2, the next evolution in memory for desktop PCs. Now for the downsides of CAMM2 for desktop PCs. Since it is still an early product, the memory modules will be expensive and difficult to get from the start. They are also slightly more complex in terms of installation, as they require screws to be held in place, but JEDEC and its partners are already working on toolless designs, so we can see better installation techniques implemented in the future as the standard goes mainstream. Lastly, MSI showcased a DDR5 7200 CAMM2 memory module running on its Z790 Project Plus motherboard. A standard and a CAMM2 motherboard were compared, with both yielding the same performance, but this was not a performance demonstration and more of a proof of concept that even in its early stage, CAMM2 performs similarly to standard SODIMM. DDR5 7200 SODIMM memory performance. DDR5 7200 CAMM2 memory performance. We have seen CAMM2 at DDR5 7800 speeds being demoed at Computex by G.Skill, and several other vendors also shows their demos, so it looks like the memory is going to take the market by storm when it starts rolling out to mainstream desktop PCs.